Hi, so today we're gonna learn about single layer perceptron. It is the simplest neural network model that is used for binary classification basically and learns by adjusting weights based on errors. So first we're gonna import the necessary libraries for this model, and then we're gonna import the penguins underscore slp.csv data CSV file and create a data frame. Next, we're gonna do the necessary data pre-processing, and uh, this is necessary so as it prepares the prepares the data for machine learning model. First we handle the missing values and then replace them with the mean columns. Now we convert that species columns into column which contains categorical labels into numerical variables. We convert the species columns which has categorical labels into numerical values using label encoder. And next we're gonna select the input features and target variable. The shape of these two frames is 100 comma 4 and 100 comma 0, as target variable has only one column, whereas uh, input features have four rows and 100 columns and one column, sorry, 100 rows and four columns. Next we need to standardize the input features and scale them so that uh, we don't have any outliers, and all the input features are in similar scales. Now we need to split the data set using test train split into size of 80 to 20%. The shape is 84, 24, 18, 20. Now we need to assign learning rate and number of iterations, all these parameters. Learning rate we have assigned as 0.01 and iterations is 100, and intercept we have assigned as 0, initial weights and initial bias. Now we need to calculate the updated weight in every iteration. So in this, for each training sample, the perceptron calculates a score using a weighted sum of inputs. If the score is greater than or equal to 0, the prediction is 1. Otherwise, the prediction is 0. This simply acts as an activation function. The prediction is incorrect. The perceptron updates the weights, and the updated weight depends on the initial parameters that we have assigned, such as learning rate, prediction error, input features. This gradually increases the model's accuracy. Now these are the final weights and final bias here. Now we need to plot the graph for each iteration against error. This graph shows how the training error changes during iterations. We need to Now we need to predict the class labels for the test set. We are testing the model, and the predicted values are these. For each test sample, the perceptron calculates a score using the trained weights. So now we need to see here that SLP is used for binary classification. Hence, predicted values are also binary ones and zeros, not of other integers or functions. If the score is greater than or equals to 0, the sample is classified as 1, otherwise the class is 0. Now we need to evaluate the model. For evaluating evaluation metrics, we are using confusion matrix, accuracy, precision, recall, F1 score. The confusion matrix shows the number of correct and incorrect predictions. Accuracy measures the overall correctness of the model. Precision measures how many predicted positives were correct. Recall measures how many actual positives are correctly identified. And F1 score measures the harmonic mean of precision and recall. Thank you. See you on the next video.